Hello, everyone. Very good evening. Am I audible?
Yes, Krishna.
Yes. Good evening.
All right. Thanks for confirming. So we will just wait for another 1 or 2 minutes and we will get started.
Hey, hello, Krishna. Good evening.
Hi, Ratnesh.
Hi, how are you?
Doing good. How are you?
Yeah, quite doing good.
How is KL treating?
It's getting well. Right now it's long holiday here,
Mhm.
Chinese New Year.
Okay,
So no work, just chilling.
great.
Mm.
All right, so we will get started. All right. Good evening, good morning, good afternoon, wherever you are. Welcome to this AWS workshop. This workshop is intended for uh, network engineers, security engineers who have proven their skills into routing, switching, and other areas of network infrastructure management. And now we know that most of the companies are moving also towards the cloud. Moving means they are moving the application services into the cloud. Uh, the physical and the campus network is still going to be there. So it is only a certain amount of resources are being hosted onto the cloud. That is your applications, right? And when we are talking about application will require underlying hardware like routers, switches, servers, and so on, right? What we do on the on-premise, same thing we are doing into the cloud, where most of the components like router, switching, uh, then your IP addressing, creating a virtual private network within the cloud is going to be exactly same what we have been doing onto the on-premise, right? It's just that we are going to use software defined networking, that is your AWS hypervisor to achieve that, right? But the logic of networking is still going to be used in the cloud as well. And that is why most of the companies are expecting that their network engineers, security engineers should know about what AWS is, what services it provides, and how you can design the similar type of infrastructure in AWS, right? Without worrying about the underlying hardware, without worrying about uh, uh, the infrastructure and so on. Your responsibility will be just looking from the logical perspective, not from the physical point of view, right? So we are going to cover a lot of things, uh, and it is going to give you a very good idea as a network engineer, as a security engineer, or as a operations engineer, how you can look into the AWS world, how you can plan your learning about AWS, what will be your roles and responsibility we are going to talk about, right? So a quick introduction. My name is Krishnanand and I have around 13 years of IT experience. I'm still associated with the company and I'm dedicatedly working on the cloud platform, that is mostly on AWS, where we are designing our own infrastructure in the AWS. That means we are creating our own private network using the underlying hardware and the software what AWS is providing. Within the uh, private network, that is VPC, we are running load balancers, we are running firewall, we are running VPN gateways, Windows, Linux, databases, everything is going to be there. But that is only for running a service, right? Employees are still going to be sitting in the office. They are still going to have the campus network, office network, branch offices, and so on. Remote users who are going to work from home and so, right? So only the applications, the servers are being hosted into the cloud. Now, since we are hosting these services in the cloud, we need to design a secure environment so that only the intended people should be able to access it and so on, right? Now, so that is what my roles and responsibility these days. Prior to this, I have worked with Infosys, I have worked with Broadcom, I have worked with Barclays and Fujitsu, where my area of expertise is more on the security side and application delivery controller, that is your load balancer. I have extensive working experience on proxy as well, Blue Code proxy, and routing switching has been the base. When it comes to about LearnITnoW, uh, along with me, there are many other people who are actively uh, associated with me. We deliver trainings based on our real-time experiences, and people have liked our approach, and that is why you have got the references to attend our session, to attend our live training programs, and so on. We believe that every individual have a capability to grow. It's just that they need a proper guidance. They need a proper training to skill up their technical skills and so on, so that they can excel in what they are doing, right? And a proper guidance can easily help you grow within your career, not only in terms of technology, but also in terms of your professional growth, like changing roles and responsibility and so on. What are our expertise? So we have expertise in AWS, we have expertise in Checkpoint, Palo Alto, FortiGate, Cisco F5, and Symantec Blue Code Proxy. These are all mostly the high-end technology a network engineer should be pursuing going forward. As your experiences grows, you will have to gradually start adding these skills in your profile. That is how you can grow financially and your professionally. That is how you are going to be recognized. If you just stick with routing switching type of role or doing the monitoring type of job, maybe you may not be able to grow either professionally neither financially, right? So you should always have a goal of adding few technologies every year, which is going to be giving you a proper benefits. Quick housekeeping thing. So now I see that around 60 people have joined approximately, right? and you have taken out some time from your busy schedule because you wanted to learn something new that can be value added to you in future. So I expect that you be focused. I will try not to extend a lot of things within this session, but will take a very simplified and easier approach to help you understand what I want to deliver and how it is going to be benefiting to you, right? So keep your phones away, focus for 1 or 1.5 hour, uh, and let's see how it is going to be benefiting you. All right. So let's quickly understand this. Before I walk through these slides and show, I just wanted to walk through few of the questions which may be related to uh, you. Like even you might be having these questions, right? So quickly to start with, why you should attend this session? Because I'm going to guide you as a network engineer or as a network security engineer, what you should be focusing on in cloud and what you should not be focusing on, right? So when it comes to any infrastructure, either you talk about the physical or cloud, right? We have various areas. For example, we have network, right? We have system, we have storage, then we have application development, right? And every domain has their own engineers, right? Storage has its own dedicated people who are having expertise on storage. System, where people have expertise in Linux administration, Windows administration, and so on. And people who are the developers, right? They are more focused on developing the application programs and so on. And when it comes to the network engineer, we have many roles like operations role, network administration, network security, load balancer, firewall management, and so on, right? These all things are going to fall under the network admin role. Now, either I talk about the physical deployment of an infrastructure or having an infrastructure in the cloud, right? These roles are going to be still the same, right? A storage administrator will not be interested in knowing how the networking is done on the cloud because he doesn't want to spend learning how the networking works, right? He is more focused on his career by focusing on more on the storage side of it. A developer cannot dedicate his time learning how network operates, how to manage. So he will be focusing more on enhancing his skill in application development and programming side of it. Same goes with your system admin as well, right? Uh, why someone has chosen going into the Linux administration, Windows administration, because they were interested in the domain and that is why they have chosen that, right? Now, since companies are moving onto the cloud, it does not mean that these people are going to learn everything and do everything as a whole, right? Everybody have their own interest, and still our roles and responsibility is going to differ from each other. So if a company is adopting a cloud for hosting services like servers, databases, hosting the applications, and so on, they also need a underlying networking in the cloud as well, right? Now, who can design a network in the cloud? It is the network engineer who knows what IP addressing are, how the routing should be taking place from one VPC to another VPC, how to route a traffic from our on-premise network to the cloud network, how to establish the VPN connection, and so on, right? How to allow a remote access VPN to work from home and access the on-premise infrastructure and access the cloud application and services, right? So always focus what you are doing right now in the physical world. You have to do the same thing in the cloud as well. You will be mostly looking onto the networking side of it, right? So keep in mind that when when you are going to join any of the class, either AWS, Azure, or maybe Google Cloud classes based on your interest, uh, try to stick to our domain. Don't focus on going for storage service like S3 bucket or Lambda function or maybe RDBMS and so on, right? Because you will not be able to do much in that side. You're interested on the networking side. Now within the cloud, when I talk about AWS, the AWS itself has a lot of networking component. Like we have VPC, which is a private network in the cloud. We have transit gateway. We have endpoint gateway. We have VPC, VPN connection. We have direct connect. We have IPsec site-to-site VPN, right? We have attachments. Then we have internet gateway, NAT gateway, and these functionalities are all related to the network engineering role, right? So you focus on what is important for your career growth and what is of your interest rather than focusing whole as a cloud concept, right? Do not just blindly spend your time learning things which are not relevant and which are not of your interest, right? So answering to this first question, why you should attend this? This is why you should attend that. You have to be focused on your networking concepts. Don't deviate from it, right? And why you should learn about, because companies are adopting the cloud for running their workloads into the cloud. They don't want to maintain a data center. They don't want to buy a costly routers, switches, and high configuration servers to run an application, right? Uh, the reason being is we may not be using those resources up to the mark what we are spending on them, right? Cloud provides a very flexibility that if you're not using a resource, you can just shut it down and you are not going to pay for it, right? So since companies are adopting the cloud, and as a network engineer, your role will be to design a secure private networking within the cloud. That is why you should be uh, adopting then or choosing why to attend these type of session. Then be competitive. Now since companies are looking for people who have now knowledge about the cloud computing, how to design a network in the cloud computing, a cloud world, if you do not upgrade yourself, you will be lying behind, right? You will be staying behind the others because people are adding the skills to be competitive in the market. And that is where you will also have to start focusing in that direction, right? So you have to start learning. Who should attend this? One who is planning to learn about AWS, right? You want to start learning AWS, you will be getting a benefit out of this session. And mostly the session is going to be focused towards the networking side of it, right? And one who is confused about what to learn in the cloud, right? So this session is going to clarify a lot of things as a network engineer, that what you should be focusing on, right? Uh, Many people come with this type of question that what to learn into the cloud. Cloud itself is a kind of huge ocean, right? In a way, when it comes to the service offering. So I'll be helping out that will help you in decide what you should focus on in learning. The one who is planning to go for certifications, right? So you can attend, learn AWS by comparing services with on-premise solution. Now, if you remember, like sometime back, I talked about network service, I talked about the system, I talked about storage, I talked about apps, right? Now, when I come to the networking side of it, right? Whatever equipments we are working on in the physical world, like we have router, we have switch, we have firewall, we have proxy devices, we have load balancer, uh, and so on, right? uh, then some other services like authentication server, radius attacks, and so on. The same thing we are going to also use in the cloud as well, but the uh, way how we connect to a router, the way how we connect to a switch, the way how we connect and manage a load balancer or a firewall, will be different in the cloud, right? So for example, when it comes to a router, we know that router enables communication between multiple subnets, right? Same way in cloud, we have the concept of transit gateway. The role of transit gateway is like a router, enabling communication between multiple subnets, multiple VPCs, and so on. Your firewall provide IPsec VPN capability. Your firewall provide NAT capability. Your firewall provide your security policy capability, right? So to achieve this, AWS has different services. They have a VPC based VPN connection. They have NAT gateway. They call it as NAT gateways. Then they have security policy. For that, they call it as security group, right? So you see that whatever we are doing in the physical world, there is a replica for all these in the cloud. It's just that AWS is selling with a different name, but the functionality of these components is going to be exactly same as what we are doing into the physical world, right? So if you start comparing what is the role of a transit gateway when it is compared with our physical infrastructure devices, then you can easily correlate that how AWS is simpler uh, uh, in the cloud as well. I mean, how it is going to be simpler for you to learn the AWS concept, right? Because you are focused on what you are doing in the on-premise and what you'll be doing on the cloud, right? So always remember that compare and be enthusiastic to learn that what we are doing on the physical infrastructure with a router, what we are doing with a NATing device, what we are doing with a firewall. If I want to achieve the same functionality into the cloud, what is the service cloud is offering in that case, right? Do we have a load balancer in the cloud? Can I use F5 load balancer in the cloud if I'm not deploying the load balancer in a physical world? Can I use a firewall in the cloud like Palo Alto, ASA, and so on? What I'm using as a physical device here? And you will be getting the answer is yes. We can run all these components in the cloud as well. And the way of working with those devices is going to be almost the same what we are doing into the physical world. All right, so why you shouldn't deviate from core technologies? The reason I gave, right? If you are a developer, you don't want to learn how networking works, what router is, what switching is, what IP addressing and things are, right? Your focus should be more on learning what you are doing now, right? So same thing goes for the network and security engineers as well. Focus on those areas in the cloud, which is relevant to your expertise and your area of interest rather than learning things which are not going to be used by you, because company is anyway going to have a developer, they are going to have a storage administrator, they are going to have a system admin who will be managing the systems into the cloud. So be focused on what you are doing now and learn things which will matter to you, right? Now know what all services can go to the cloud, right? Now, as I mentioned, adopting cloud does not mean that company is completely moving into the cloud, right? If a company like Infosys, Wipro, TCS, Cognizant, they have employee base of 2 lakhs, 3 lakhs, they need the physical presence, right? People cannot go into the cloud to work, right? Some are the other place they have to go and work from there. They need internet connection, they need routers, switches for internal communication within the offices, right? So don't consider that since companies are adopting the cloud, uh, network engineers or jobs are going to be eaten up or so, right? It's not like that. Everything is still going to be there. Just be focused that some of the things like having a small data center in our campus for hosting some application servers and so these can be deployed on the cloud, but employees are still going to go to office, employees are still going to use their laptop to connect to our office network using the remote access VPN, which will be managed by a security engineer and a network engineer, right? So don't be scared with that. uh, just focus on what is relevant to your career growth, right? Then why companies are moving services to the cloud? One, the infrastructure cost. For example, if I want to set up a small infrastructure in my office itself, right? I need to reserve a place, right? It should be well maintained from the cooling facility, power backup, alarm facility, right? Security guards and so on. Then I will have to deploy a lot of switches, then the routers, internet connection, a redundant internet connection. Then we'll have to have a firewall in place for security. I will have to buy the rack servers, right? Uh, Depending on the application usability, I may need to have every device is redundant and so on. And then to manage this infrastructure, I need to have engineers, right? Who should be managing the networking side of it, who should be managing the system administration, storage, then the application development side of it, right? So this infrastructure, setting up a data center on its own, has lots of costing involved within this, right? Then comes the operational cost on top of it. Purchasing a hardware is one costing, and maintaining the hardware is another costing. What if my application does not work well? What if my business did not go well with this particular infrastructure, right? It's a waste of resource, it's a waste of money now, that I cannot use this infrastructure for any other purpose, right? But when it comes to uh, running the same workload in the cloud, you are just paying for the infrastructure what you are using. And you are not worried about purchasing the hardwares here like routers, switches, and so on. You are running every application into the virtual machine in the cloud. The infrastructure is being taken care by your AWS or Azure or Google, right? You will not have to be worried about the capacity planning. For example, let's say today you develop a small application, let's say consider uh, Ola or maybe Uber application. You targeted just, let's say, Pune city, that you will be providing a Ola Uber type of service in Pune city, and looking at the tremendous response from the customer, you wanted to move to some other metro cities as well, right? Let's say uh, Bangalore, Mumbai, Hyderabad, and so on. Now you are expanding your business, so you may not be able to plan the capacity of your infrastructure. Maybe you thought that just having let's say 10 to 15 hardwares for running the applications and so on will be able to serve the need, but the user showed lot of response in that case, and your existing infrastructure is no longer going to be able to serve the need of the users or the application. So what will happen in that case? You will have to spend more purchases and so on. There can be a possibility that you may not be able to use each and every component up to the 100%, right? So it's a waste of money that you have already spent and so on. But in case of the cloud, you will be paying only for what you are using. If you are not using anything, you can simply just drop that service, drop that infrastructure, and no cost will be required in that case. In the case of your physical type setup, the time to procure and deploy is lengthy. For example, if I have a data center, let's say, application team is adding some of the functionality into the business application, and they need some extra storage, they need some extra compute power, right? uh, where they may need to have some, let's say 5 to 10 servers from IBM or Dell, Blade servers and so on, right? Now, purchasing these equipments from the vendors has a process. You cannot simply just place an order and it will be delivered immediately, right? There has to be a process to procure. Approval will be required for this infrastructure, or purchasing these components and so, right? And then once a device is delivered to you, a specific type of expertise will be required to manage it. For example, if it is a storage device, you will have to involve storage team. If it is a server type of device, you will have to involve server team. Network team needs to be involved, whether they have the enough ports to connect these components onto the network or not. And this is going to be a time consuming process, right? Whereas in the case of cloud, company will not have to be worried about all these things. They are, cloud provider is already providing you all this infrastructure in the background. They are saying that you need 10 compute devices, let's say. You can spin it within a 1 or 2 click. You can just run a script and your 10 servers can be ready. You need a terabyte or petabyte of storage. You have to just click on it, attach to your compute devices, and the storage will be available for you as per your demand. So as a company, as a business owner, my focus will be mainly on developing the application that is going to serve the need of the end users, right? I will not have to be worried about the underlying infrastructure, procurement, setup of this, all these things, and management side of it. It is taken care by the AWS in that case, right? Now, the other challenge is, what if your infrastructure is not being used up to the mark, right? You spend a lot of money setting up a data center and so on. And let's say your application failed, for example, it did not do well what you expected, right? Now it's a waste of your infrastructure, right? You have already leased a building. You have already procured all the devices. You have to make sure that it is operational, even if you have less customers as well, you have to serve them, right? But your infrastructure is not being used up to the mark and you have already spent a lot of money on that. So that is going to be a wastage of resource, and that is how cloud is going to solve those type of challenges, right? If your resource is not needed, right, you can simply shut down the resource. Let's say more users are dropping from your business, shut down these resources, run with just 2 machines, right? And you will be paying only for what you are using into the cloud. So that is how cloud is solving the problem of resource management, infrastructure cost, capacity planning will not be required. You can quickly spin up the resources as you need, as per your requirement, right? And there is no uh, uh, special procurement process and so on. You have to just click something and your infrastructure can be ready for you to use, right? So that is why you should be focusing on learning the cloud, because companies are looking at these things, right? There is a lot of things involved into setting up a on-premise data center, and that is why companies are moving more services into the cloud. All right. Does anybody have any questions so far before I move on to further discussion? No questions? All right, great. So let us quickly, yes, Akash, I'll take a quick question.
Hello, hi everyone. Hi Krishna, Akash here from Bangalore.
Yes.
I just wanted to know, you're just briefing out the cloud architecture here, correct? This session.
Right, and I'll be also talking about how do we design architecture into the AWS.
Okay.
So I'll be talking about the logical approach of designing a network into the AWS. And it's a standard practice.
Last week, I couldn't
join
on the session. Is this the continuation of the last week's session?
No, it's not a continuation. It is the same session. I'm repeating on demand.
Okay, that's great. I just wanted to know, because I said you right had missed the session. So just wanted to know, if it is a continuation part, I just wanted to have a recorded video or something of the previous session.
No. It's the same session. I'm just repeating it.
Oh, that's great. That's great. Thank you, Krishna.
All right. So we'll continue with this. So what does this traditional network architecture mean here? If you look at this design, right, This is, let's say, a campus network we can consider. Campus network like Infosys Wipro campus, where it can be Pune, Bangalore, Hyderabad. So the employees area is, this is where maybe 10,000 employees, 20,000 employees, or maybe in some campuses, a company can accommodate around 50,000 employees as well, including all networking components, right? So how the architecture is, the end computing devices generally connect to the access switches, that is your layer 2 switches. There can be some wireless access points as well for hybrid type of connectivity. And then we'll have the distribution layer and the aggregation layer switches, right, which are mostly used for VLAN segregation and doing the routing stuff. These are all layer 3 and multi-layer switches, right? Then we will be having, let's say, maybe core routers. We can have core routers here, like Nexus type of devices, and they will be connecting with this aggregation switches. Then we will be having the firewall here, right, for the security purpose. And then it will be connecting to the internet side, that is WAN. And company may have multiple internet connections terminating onto the firewalls, right? For redundancy and reliability and so on. So if one of the ISP fails, there should be another ISP which can allow the users to go onto the internet. Not only to go onto the internet, maybe a company is having this data center here where they are running the business application, right? It can be your Facebook application, it can be your Instagram, it can be Ola, Uber application hosted in your campus network data center, right? So the users who access those business applications, their traffic will be flowing through these ISP firewall routers, then to this, and logically it will be hitting into the data center, right? So the physical infrastructure, what I spoke earlier, right? It requires a lot of effort in management, procurement, configuration, operations, and so on, right? Which is a very lengthy process, and this can be a very, very costlier solution for a company to set up a data center, right? There is a reliability required at every stage. A company may be paying crores of rupees just for internet connection, right? Having a reliable internet connection, because uh, through these internet connections only company is doing business with other customers. Like company have a project of let's say US or maybe from the UK and so on, and employees sitting here are relying on this infrastructure, right? So there is a huge costing in the traditional network, even if I just talk about the inside of a data center, right? So within the data center, this entire architecture will be there as well, even if it is in a standalone building or so, right? So let us quickly have a look what we see inside of the data center. For example, let's say we can have similar type of setup in the data center. So we have internet providers here, redundant internet providers. Then we have the WAN routers, which are going to be participating into the BGP routing and so on. And then we have the security devices here, like firewall, and then the core routers where the routing process will be running. And ultimately, for connecting the backend servers, we will be having all these access switches, right? Now, servers may be in more volume in a data center, maybe 200 server, 500, or even more than that. Because even if I talk about a single application, business application, let's say if I talk about Facebook, for example, or maybe Ola or Uber, right? Ola will have a front end application like HTML page or PHP page. For that, it requires a server. It may have a database server so that whenever a customer is creating an account on Ola, there will be a database maintained. There will be a navigating system that will be helping customers to locate the cabs and so on, book the cabs. How many times customer have booked that cab, how many times services he has taken. All these things are going to be recorded into the databases, right? So there may be hundreds, thousands of systems within the data center relying on all these components, right? And the physical layer infrastructure has its own requirement, like making sure that the data center is in a secure place. It is secure from any natural calamities and so on. And it is highly secure with CCTV cameras and so on. And that is how a business is driven, right? uh, what we see as a customer is a front end side of it. We don't realize how huge infrastructure is required to run that application so that our ease of access will be smoother, right? Who is taking care of it? That is the business. Like the companies are making sure that the customers are always satisfied with service what they're offering, and there is a underlying cost involved within that. Now, this cost may be of no use if your application is not working properly, right? And to make sure that this is working properly, you need to keep it operational and take care of this infrastructure and make sure that it is well maintained and so, right? So what it takes to set up a data center? Even if I talk about a mini data center in a campus network, all these components are still going to be the same, right? Even if I have just 2 racks, for example, let's say I'll simply consider this one, right? These racks will require dual power supply, backup, dual internet connections, multiple switches, multiple servers, routers, firewall, and so on. The cooling facility, right? Making sure that uh, this access to this hub room is secured with the access control system. Authorized people are going into the data center for the activity, security guard, and then the teams who manages the infrastructure, like managing the server, there will be server team. Managing the network, there will be a network team. Managing the security of this data center, there should be a firewall team, and so on, right? If the applications are being load balanced, there will be a load balancer within this racks there, and those has to be managed by different teams, right? So you can see that there is a huge infrastructure requirement with huge uh, investment requirement in this particular case, right? So power management will require UPS, power distribution, separating two sources of power, and so on. All right. Then rack mounting, uh, power panels, rack power distribution, static transit switches, and so on. When it comes to the rack accessories, we have modular rack accessories, and so on. Cooling facility, row columns, and so on, where you are going to place what type of devices. And within the management part, infrastructure manager, right? People who are managing for responsible for managing the data center facility. Environment status, environment probing, like whether your fire systems are working properly, your alarm systems are working properly or not. All these things has to be taken care uh, while setting up a data center, right? The the system design and planning, rapid and comprehensive services. Now, whenever there is a need to add any device into the uh, a data center, right? Again, it goes through the procurement process. Devices will be delivered to you. Someone has to go and rack mount it, and so on. So there is a uh, huge effort required, huge amount of uh, capital is required in setting up and operating a data center. This is one of the data center we can assume. Either it can be from Facebook, Google controls, or maybe uh, there are many companies who are setting up the data centers and so on. Amazon is setting up the similar type of data centers. So this entire facility, like the building, inside of the facility, operation of the operational management, procurement of all these components is now being taken by the uh, cloud. If we are going to opt for, if you're not opting the cloud service, you will have to do all these things on your own as a company. right? So companies spend lot of infrastructure, lot of capital on setting up these type of facility to serve a need of the customers. All right, so why AWS, or what AWS is doing here, right? So when it comes to AWS, we always think of cloud, right? Because they are the one who started the cloud concept. Now, what AWS is providing is uh, AWS is providing a highly available, secure cloud service platform that offers more than 100 cloud applications. Now, what is cloud application? As I said, everything in the cloud is sold in the form of service. You want to achieve the routing capability, you will have to find the you will have to use a transit gateway service. You want to set up a let's say NAT capability to translate your private IP addresses to go onto the internet with a public IP address, you will be using the NAT gateway, right? We need to have a connection from private network to the internet. You need to have a IGW, internet gateway. You want to connect your cloud servers with on-premise data center for transferring the data and so on. We need to have either direct connect service, or we can have a IPsec VPN service that we can configure between the cloud VPC VPN gateway and our firewall on the on-premise network. Like it can be a router, Palo Alto firewall, Checkpoint firewall, or so, right? So everything is being sold as a service in the cloud, and you will be paying for what you are using, right? You are not going to pay for what you're not using at all. You can shut down that service, you can terminate the service immediately if you're not using it, right? Then it helps in controlling, auditing, and managing the identity and configuration and usage into the cloud. So you get a flexibility from a account level, that who is doing what into the cloud, right? Let's say network engineers will have access only to the network components. System engineers can have access only to the system components. Storage will have access to the storage, and so on. So you get a very good audit report for everything that is happening into the cloud. And at the same time, you also be getting a report about your infrastructure, like how you are using the infrastructure in the cloud. For example, you have uh, spinned up 2-3 virtual machines, right? But these virtual machines are not being used up to the mark. Let's say they have 16 GB of RAM, let's say 4 CPU, and let's say 1 TB of hard disk, right? When you look at the utilization of these resources, they are not using these resources up to the mark. That means you can easily reduce the capacity of these resources to, let's say, 8 GB instead of using the 16 GB. So you are cutting down the cost of the infrastructure in that case, right? And that is how AWS is helping customers uh, uh, use the resources as per their needs and pay what they are using for, right? So what AWS is offering, they are offering the compute power. You will not have to worry from where you are getting the power into the virtual machine. There can be multiple servers behind the scene from where your virtual machine is getting the RAM, CPU, and the storage, right? All you are concerned about is, I wanted to have a 16 GB of PC, I'm getting that. I wanted to have a 4 CPU in this, I'm getting that. I wanted to have 2 TB of storage, I can quickly get that. You are not worrying about from where that AWS is providing. It is the responsibility of AWS that whenever you need a resource, it should be always available for you. You will not have to wait for the purchase order. You will not have to wait for the device to be delivered to your infrastructure and so on. You can do all these things within a single click, right? Then database storage is there. They are providing the secure platform. That means AWS is making sure that how a customer maintains a data center on their on-premise network, how a customer is having their private network secure in a campus network. Similarly, they are providing a secure environment reliable with power supply, cooling, internet backup, high-speed internet connectivity, and so on. That is going to be taken care by your AWS itself, right? All you have to do is you will be just putting the content what you want to host into the cloud. And for that, AWS is also providing the faster content delivery. They are having various mechanisms through which, for example, you don't want to use this data center anymore. You want to run all this workload from this data center into the cloud. AWS provide you flexibility to use direct connect circuit, high speed direct connect circuit to transfer all the file storage and everything into the cloud. In many cases, some of the data cannot be easily transferred through this. They also provide you a capability that you can take a device from AWS to your infrastructure within your data center, copy all the files what you need to that device, and ship that device into the AWS data center. And AWS team will be making sure that your data is hosted now on the virtual machines where you want. If you want to use that hardware itself as a component for running your application, you can do that as well. So that is how flexible and ease of management they are providing to the customers. Right now, this is very important to know that AWS has presence across the globe. Right, we can see that within India. Right, within India, we have 2 data centers managed by AWS. One is in Mumbai and other one is in Hyderabad, right? Like this, they have presence across the globe. Now, let's say I have a business. Initially, I targeted India customers, and looking at the response from the India users, I see that I have a scope of running the same business in North America. I have a scope of running the business in any other component, any other continent or any other country, right? So I will not have to plan my data center setup in these regions. It is already taken care by the AWS. All I have to do is replicate the application setup from one AWS region to another region, and that can be done with a faster speed because your AWS has a high speed connectivity from one data center to other data center. So you can easily transfer the file very faster and quickly, and that too in a very reliable way, right? So spinning up a equivalent type of data center or equivalent type of resources from one region to another region is like we can do it within 1 or 2 days time. But when it comes to the physical data center setup, it may require years and years of time to replicate the same type of configuration in other regions and so on. Another advantage of using the cloud services, you can target the customer, right? For example, if the customers are more into the North America, you will be choosing a AWS data center which is closest to the North America users, and you will run all the workload here, right? So users will not be facing latency delay while accessing the application, and that is how AWS is solving the problem of latency slowness type of issues by helping you host your services closest to the users, right? And it's very easy to replicate the workload from one region to another region. What basically you get as a customer when you start using the AWS service, right? So let's say this is one of the data center in Mumbai, and our customers are also, let's say, from the Asia Pacific region, right? Now, as a company owner, as a business owner, what I will be doing, let's say this is my company administrator, cloud administrator. He will have to have an account into the AWS. Using that account, I can create a virtual network with the help of these resources, what AWS is providing. And within this, I will be having virtual servers where I can run Linux, Windows. Then I can have a virtual machine where I can run a firewall. I can have a virtual machine where I can run a load balancer, right? And through this, users will be able to access the resources what we are hosting in this, right? So we are trying to host the services closest to the users, right? And as an administrator, you are taking the advantage of the data center what is nearest to us, where we can set up a private type of network within the cloud. Now this network what we are using here as a private, we call it as a VPC, right? Virtual private compute, right? And the resources what we are hosting here cannot be accessed by any other company or other users who are also using the AWS in the same data center, right? It is a logically separate network and it is well controlled and managed by a company administrator, right? So within the Mumbai data center, let's say I have my own VPC. There is another company who is also using the AWS cloud in the Mumbai data center, but their data will not be able to uh, uh, mix up with our data. Their computing devices cannot communicate with our computing devices, even though we are using the same underlying hardware here, right? That is how they are controlling the security within the cloud as well. Now, not everything is being managed by AWS. It is the responsibility of this company administrators as well, right? So network engineer will take care of the networking side of it. Storage engineer will look at the storage, and system it will be taking care of the system side of the administration. What is cloud computing then? It is providing a high compute capacity. It provides 24/7 access to your account. That means there is no restriction that if it is a night time, you cannot run a machine. There is no restriction that after 6 p.m. you will not be able to take a hardware into the office or into the hub room, right? This AWS is accessible 24/7. Let's say you need a resource in the midnight, you want to run a EC2 instance, a virtual machine, you can run this anytime. It provides you 24/7 accessibility. You pay for what you are using. You will not have to pay what you are not using, right? It reduces the total cost of operations. Now, what do you mean by total cost of operation here? I'm not worried about from where I'm getting the power supply. I'm not worried about the security of the infrastructure. I'm not worried about the cooling facility. I'm not worrying about the infrastructure on which my data center is set up. It is being taken care by the AWS itself. All I'm worried about is about the virtual machine what I'm going to use into the cloud. I'll be responsible as a customer for these things, right? The machine what I'm using, application what is running within this, I will be more concerned about this part, not about the underlying cost and so on. AWS is providing this infrastructure in a reliable, scalable, and sustainable way. What do you mean by this? Reliable, because within the data center, they have logical separation. Let's say availability zone, right? And let's say if you are running a application, you can run a application in different availability zone machines. One virtual machine is in a availability zone 1, other one is in, let's say, B, and other one is in C. So if one of the availability zone is down, it's a logical separation within the data center. Let's say the servers, what they are using here, the physical component, if there is something wrong in this area, it is not going to impact this and this one. Let's say even this area is impacted with fire or so, you still have a logical area where we have powerful servers and your machines are still powered up through this particular infrastructure, right? It provides secure storage management where they are using the encryption and so on to make sure that your data is highly secure. Device and location independent. Now you are not depending on the location, right? Let's say, as I said, today you are running the workload in Mumbai data center, and now you want to replicate this same thing in the North America. You can easily do that within a 1 or 2 days time. But when it comes to the physical one, you may take years and so of time, right? Then easy and agile deployment. That means you can easily manage and configure things into the cloud, right? You will not have to follow a long, lengthy process of approval and so on. Of course, there will be some change management process, but that's a logical change management process, not related to the physical movement and so on, right? Highly automated and frees up the internal resources, right? So whenever you are not using a resource, you can easily release that resource and you are saving the costing on top of it, right? So that is how your AWS is solving a lot of infrastructure problems, right? The same thing we have discussed here earlier. You will be paying only for what you are using. So pay as you go. The benefit from massive economic scale, right? You will not have to plan for infrastructure well in advance. You can spin the resources as per your need. For example, there is a sale starting for Flipkart, right? Now, Flipkart will not have to uh, plan for the hardware procurement well in advance to meet up this sale requirement, right? They know that I can do that within a single click and I can get the resources how much I need it. But if this was a physical type of requirement, Flipkart would have to start this planning well in advance, maybe 6 months or 5 months prior. For example, they wanted to go with a 25% flat off during the Diwali season, right? So they are expecting that during this festival, user count will be more on the Flipkart website, and to cater the need of these users, they need this underlying infrastructure, right? So if this was their physical data center, they would have to start the planning well in advance, maybe 5-6 months before, because they have to go through procurement, configuration, then add the devices into the data center, configure them, connect them to the network, and so on. Make sure that if their internet capacity is not up to the mark, increase those things and so on. But when it comes to the AWS, you can scale anytime. You will not have to be looking at all this at all, right? Because AWS has taken care of all the infrastructure, underlying infrastructure. Stop guessing the capacity. This is another very useful scenario, right? You will not have to guess that during the Diwali season, maybe I will have to buy 10 servers and so on. My internet capacity should be, let's say, from 10 gig to 20 gig, right? Uh, you will not have to worry about it. AWS has already taken care of it. As your needs grows, you can start consuming the infrastructure from the AWS. If your need is fulfilled, let's say Diwali sale is done, you no longer need more internet bandwidth, you no longer need the compute resources, just shut them down, and then you are not paying for it, right? It increases speed and agility. What do you mean by speed and agility? Now, since you are not going for the procurement and configuration and other side of it, you will be more focusing on the development side of your application. Your more focus will be like develop the new features and so on, and quickly deploy it into the cloud. You will not have to go for a test environment, development environment setup, and then finally your application will be going into the production. You can do everything just within a single click or so. You will not have to also realize on the costing side of it. Why? Because you can pay what you are using for. If you are not using, you can just release it, right? So you will not have to be worrying about that, how much costing it is going to take, right? And go global in a minute. As I said, if you are running 50 servers in Mumbai data center and you want to replicate the same set of servers in, let's say, North America and one in Europe region, you will not have to be uh, depending on the logistic the purchase of equipment and so on. You already have the AWS data center in all the regions. All you have to do is transfer these databases, uh, uh, duplicate the EC2 instances and run it into the other region of the AWS, and your applications will be up and running within 2 or 3 days of time, right? And so on. Then cloud computing models. What do you mean by this? Infrastructure as a service. That means you will not have to be worried about the hardware components, right? Routers, server, power supply, internet connection, and so on. You are not worrying about it. What you are worrying about is you are renting a virtual machine, which is taking the resources from AWS hardwares, what is there in the their data center, right? Now, you needed 16 GB of RAM. You are able to get the resources from these physical machines. What you will be doing is you will be running your own operating system here. Either you can run Windows, either you can run Linux, you can run a firewall operating system like Pan OS and so on, and you will be responsible only for managing this one. Right? So you are using their infrastructure as a service. You are leasing or renting their infrastructure as a service, and you are paying only for what you are using, not for what they have deployed in the data center. Right? So in the infrastructure as a service concept, AWS is responsible for managing the entire facility, either the building, the hardware, power, cooling, security of the infrastructure, everything will be taken care by them. You will be responsible for what you are running in this virtual machine, right? So what operating system you are running, what type of data you are storing, what type of application you are running to run the service, that will be your responsibility. Then the other one what we have is platform as a service. What is platform as a service? Let's say you have a code. Let's say you have a web page developed for your website. Now to run this website, you need to have a system. Let's say a server. Server needs to have either a Windows machine or a Linux machine. Let's say I'll take another type of this. Right? Your server needs to have a Windows or Linux type of operating system. On top of it, you will need a web application, like it can be Apache or maybe IIS type of application that can run a service, web service, right? And then the code what your web developer has developed a HTML page or a PHP page, you will be requiring the storage on this to store that page here, right? Like hard disk storage and so on. So all these things are going to be required to host a service, right? Now what AWS is saying, you don't worry about even this part. You will not be worrying about this virtual machine as well. Don't spin a virtual machine. What we are doing is we are providing you a platform where, let's say, I will call it as a storage platform. Storage. They call it as, let's say, S3 bucket, right? What they are saying is you have a web page, you have developed a website, just put all these files in our storage, right? And this can run as a service. You will not need any CPU here. You will not need RAM. You will not need, let's say, storage. You will not even need a Windows or a Linux operating system, neither any application. We are taking care of everything here. You just focus on your code, the website code, and just put it here, and your website can be operational just with the platform as a service, right? So you will be focusing as a customer only on developing what your business needs. You will not be worrying about the underlying infrastructure. You just put the code in their infrastructure and you will be able to use it, right? So that is what platform as a service means. They are providing everything to you. Just dump the file and that application will be accessible from outside. The other thing is software as a service. Now, best example for this I can take is, let us say we have a company, let's say Infosys, Wipro or so. Now every company have a DNS server. DNS, right? Now, what is the role of a DNS server? It can resolve the IP address to a name and name to a IP address, right? Now, to run this DNS server, DNS service, we need to have a server, right? It can be from Dell, IBM. Then we need to have either a Windows machine or a Linux machine. And on top of it, we will be running a DNS application. Like if it is a Windows, I will have to run a Windows Active Directory service. And within that, I will be getting the DNS service functionality. Within the Linux, we have a DNS service functionality where we can run a DNS service, and then we can use this system as a DNS server. If I don't want to go with this approach, there are vendors like we have Infoblox. We have Blue Cat, right? Then we have PHP, and there are many other vendors as well within the market who are providing the DDI type of facility, DHCP, DNS, and IP address management, right? So either you have to purchase a hardware from these vendors, or you will have to set up something like this to run a DNS service. What AWS is saying, don't worry about any of these things. We have a DNS service running as Route 53. Their service name is Route 53. You have an account on AWS, you can use our service, and you can start creating your DNS records here, right? So you are not worrying about the hardware. You are not worrying about the operating system. Neither you are worrying about purchasing a device from any of these vendors to run the DNS service. AWS already have a service with the name Route 53. All you have to create is, let's say you want to create a record for your website, www.abc.com, pointing to our IP address, right? Just create it into Route 53. We will take care of how to resolve. If a user is doing a query of www.abc.com, his query will hit onto the Route 53. Route 53 will be looking into this record and it sees what is the IP address for this one. And we will be providing the IP address to the user, and then user can access your website wherever you have hosted into the cloud. So this is a completely software as a service. They have taken care of the hardware. They have taken care of the operating system required to run this service. And they have also developed the DNS software as well in the form of Route 53. So you will not have to think of Windows Active Directory. You will not have to think of these softwares to run a DNS service, right? You just buy the service, start creating the record within that. You can create record like a record, PTR record, or a CNAME or alias record directly into their software. That is Route 53. All right. Well architected infrastructure. What do you mean by this? AWS has taken care of everything, like how you want your data center to be in your network. Same way, AWS is making sure that the data center is highly secure. They are highly operational. That means they have the skilled engineers who are managing their data center, right? There are people who are still carrying the hardware switches, routers, firewalls, and the high configuration servers into the AWS data center, and they are managing all these things for us, right? So still there is a network engineer role who is going into the data center and doing all these type of configuration. So they have the operational excellence by deploying the skilled engineers, network engineers, storage engineers, system engineers, and so on. They are taking care of the operational excellence of their data center, providing the cloud service. They are also taking care of the security. That means premise security and the logical security, like making sure that your data is encrypted and only the authorized people have access to the data, right? So they never mix up the one company data with another company. It is logically separated within the cloud. Reliability. Now, what I told earlier is within the data center, let's say this is your Mumbai data center of AWS. What they are doing is they are logically separating this data center into the concept called availability zone. Availability zone. There are, let's say, in some data center, they may have availability zone A and B. And in some, they have A, B, and C, three availability zones. Whatever system you are running, you can have systems running in different availability zone, so that if, let's say, this area is impacted, the other compute devices will be operational here and you will be able to run your business with that. Performance efficiency means you get a option to monitor how much your resources are utilized, virtual resources. If you are not using the resources up to the mark, let's say uh, you have chosen a high configuration virtual machine, but your virtual machine or machine is not really being used up to that marks, right? So looking at 1 month data or 6 month data, you decide that now I will reduce the size of this virtual machine to a lower size, right? So that way you are able to monitor the performance of your machines. If their performance is always high, that is on a peak utilization in terms of memory and CPU, you can monitor that as well. And then you can decide what to do with that resource. You want to increase the capacity or you want to decrease the capacity. Cost optimization. How it is going to be cost optimization? You will not have to have a huge capital for setting up the data center, right? Because this service is pay as you go. Whatever you are using, you will be paying for that. You are not using it, you are not paying for it, right? And that is how you are going to save the cost. So companies are more focused on this side of it because it provides a cost effectiveness, right? Sustainability. What is sustainability? Your infrastructure is designed, the data center is designed in such a way that as your needs grows, the data center capacity can be increased very rapidly. So they have the infrastructure developed in such a way that they can add more compute resources as per your requirement. All right. Anybody have any questions you wanted to ask before I move on to the another slide?
Hi sir, this is Surendra here. I have one question. Since they have mentioned like infrastructure as a service, so they are also planning for daily operations or what we can say the MSSP kind of environment as a rent service from them.
It is already a rental service, right? That you are paying for what you are using.
Means daily operations, like everything which is a daily business operation. So calls and everything. So
They already have the AWS support center, right? Who is taking care of it.
Okay.
AWS already have their support center, right? The customer who are using the AWS services, they can open up a case with the AWS and they get a proper support from their support teams. They already have the operational team. And there is a
means suppose we are using everything from them in terms of every technology. So जैसे हम daily calls वगैरह होते हैं ना, daily calls internal सारे teams के, so that type of daily calls they have, or they
no
have that facility?
no, they will not be having any call with you. You will have to raise a case with them whenever you need their help, right? So जब भी आप AWS में अपना प्राइवेट नेटवर्क सेटअप करते हो, जिसको हम बोलते हैं VPC, ठीक है? इसके अंदर आप जो भी सर्विसेज रन करते हो, whatever services you are running, either it is a EC2 instance, either it is a Route 53 or so, this entire operational within this VPC will be taken care by the company. It is not the responsibility of AWS, right? So this is where the role of network engineer, system administrator, database administrator, or developer comes into the picture. That anything related to the reachability from one EC2 to other, from one VPC to other VPC has to be taken care. Network engineer will come into the picture. If there is any problem related to the Windows or the Linux machine running on these EC2, the system administrator will come into the picture. If there is a security policy requirement in this virtual machine which is running, let's say Palo Alto firewall or checkpoint firewall, so security engineer will be required to configure the policy to allow communication, right? So within the inside of the VPC, it is your responsibility. If something is not working the way you are expecting and the way AWS is saying that it should work, then you will have to engage the AWS resource to look into it, and they will be letting you know whether you have done any wrong configuration or is there anything to be done on their side, right? So जैसे एक कंपनी जो है अपना ऑन प्रीमाइस डेटा सेंटर या अपना ऑन प्रीमाइस ऑपरेशन टीम यहाँ पे मैनेज करती है, कंपनी का सेम रिस्पॉन्सिबिलिटी यहाँ पे भी है. So let's say you are a network engineer and security engineer of the company. You are responsible for the on-premise network devices like routers, switches, and so on. And parallelly, you are also responsible for the connectivity within the cloud, right? So you can have the call among your own company's team, like network team, system team, storage team can have a daily operational call within yourself. But anything that you think that it is beyond your control and you need the help from the AWS to look into it, you will have to open a case with them and they will be providing you the support on that side.
Okay, sir. Yeah, got it. Thank you.
All right. So as I mentioned that AWS has data centers in many regions, and each region is highly connected with a high speed internet access, right? So you see that the connectivity between each data center is with a high speed, and they have dual connectivity from one data center to another data center. So data transfer can be very fast. And at the same time, let's say by any mean, if one of the link goes down, you still have multiple ways to reach and communicate with other data centers within the AWS marketplace. What you do as a customer, let's say a company has taken the AWS service and they are appointing you as a, let's say, administrator, right? So you will be given a account, AWS account. And within the AWS, let's say AWS have all these compute devices. They have these racks, and within the rack, they have the high performing servers, routers, switches, and so on. They have done all the connectivity with the fiber optic cables and so on, right? Deploying Nexus ACI type of infrastructure for high speed data transfer and so on, right? Now, that will be taken care by the AWS. Now, as a AWS customer, since you have a account as a network administrator, once you log in into the AWS, your role will be limited to your VPC, virtual private compute, right? Now, within this VPC, let's say you want to allow communication from one IP subnet to another IP subnet. Some computers are in, let's say, this network, and some computers are in this network. Some computers need access to the internet, and some may not need access to the internet. They are private within this network, right? Some computers may also need to communicate with your on-premise data center, for example, to get some database from here, right? So you will be responsible for establishing the connectivity from your AWS VPC to the data center, on-premise data center, and you will also be responsible for allowing communication for some of the computer who wants to go onto the internet. So this is the role of a network engineer. Let's say you have one VPC in Mumbai region, and we have another VPC in the North America region. So you also want to allow communication from one VPC to another VPC. So computer from this private IP address can communicate with the computers in this private network, right? Which is owned by the same company. Same administrator is responsible for managing. So you will be allowing with the VPC peering or type of attachment type of connections and so on, right? So that is how the roles and responsibilities are segregated within the cloud from the company's point of view and from your expertise point of view. So you will be mostly looking on the connectivity side within the cloud. The other teams like system and storage, they will be looking into their side of it. What AWS says is having a customer is a good thing, but we have to have a shared responsibility. For example, AWS says that we are taking care of the physical component and infrastructure and so on. What is your responsibility in that case is you are responsible for what you are running into our infrastructure, right? So for example, you are running a virtual machine. Now it is your responsibility whether you want to run a Linux in that, or you want to run a load balancer in that, or you want to run a firewall in that virtual machine. You have to take care of it. We can provide you a virtual machine, and in that what you want to run, it is your responsibility, right? So you see that AWS is taking care of compute power, storage, hypervisor. Hypervisor is like your VMware ESX service, right? Here the hypervisor is AWS, right? This is an on-premise type of hypervisor, and AWS is like a cloud-based hypervisor what we are using, right? And using all these things, we are able to create virtual machine. Now, the responsibility of a company who is opting for this AWS service is what you are running within this virtual machine. It will be your responsibility to manage them, right? So what AWS says here is our responsibility is this: in infrastructure as a service, we will take care of virtualization, networking, hardware, server, physical components, and so on. You are responsible for running the OS on the virtual machine, maintaining your database, maintaining the security of your data, and how to configure the application on a virtual machine. If you are going for the platform as a service, we will take care of everything here. You just dump the code, the website code in our platform, and you will be just managing your code here, your website code. You will not be worrying about all these things. And in software as a service, they are taking care of everything. You just subscribe for the service and you can start using it as an application. You will not have to be worried about how we are doing that, right? So the customer responsibility is what you are running inside of the virtual machine, and AWS responsibility is the underlying hardware infrastructure and so on. So they will be taking care of compute power and so on. And we will be taking care of what we are running inside of the virtual machine in the cloud. This is the same thing what we have already seen in the earlier slide. So as a customer, as a AWS customer, we are responsible for all this. Managing the application, operating system, running the networking side of it within the VPC, right? Within your virtual private network, how you want the connectivity will be, what firewall you want to use, you will be taking care of it. What AWS is going to do, they will provide you compute power, storage, database, underlying networking like switches, routers, connectivity, internet side of it. And they are providing you the regions where you want to run the workloads. They are providing availability zone and edge locations for the application to run it. All right. Now from here, it may looks very interesting for you when we start comparing it. This is what I was saying, that when you are planning to learn AWS, always try to compare with the existing setup. It will become easier for you to learn and visualize. So what we see here, let's say we are having a application. Let's say I will consider Ola application, right? How does a user accesses Ola? Let's say you are having a mobile phone, right? You download the application, you create an account on the Ola application, and that account information will be stored somewhere in a database. For example, about your account, right? Now, whatever money you are depositing, how many times you are booking the cab, everything will be stored into the database. To access this database, you need to have the database server. You may need to have a web application, the front facing application, what will be seen into the mobile phone and so on. But to deliver this database up to the end user, to provide an interface to the end user, a company has to set up all these underlying infrastructure, a reliable infrastructure, so that users can always access the application and the database related to it. Now, you want to replicate this entire setup into the AWS, right? So what is this setup is? This is your private data center in a way, for example, right? This is a company managed data center where the Ola application is hosted. Now you want to create a similar type of setup in the AWS, right? So let's say in AWS, right, this is the Mumbai data center, and within the Mumbai data center, I'm creating a VPC, for example, a virtual private computing network. Let's say this is my VPC in the Mumbai data center. Now this VPC is divided into two availability zones, for example, availability zone A and availability zone B, right? Within this, you will have to choose a IP subnet. For example, for this entire virtual private compute, let's say you want to use 10.10.0.0/16. Now this /16 can be further divided into 10.10.1.0/24, 10.10.2.0/24, right? Like this, you can have multiples CIDR blocks within this main block, right? Now, one CIDR block you want to use for web servers, which are in one availability zone, and one CIDR you want to use for a web server which is in a different availability zone, right? Then you want to have a database service running in another subnet, right? So let's say this one is 10.10.1 subnet in the VPC. This is 10.10.2. This is 10.10.3, and this is 4. Now we are talking about 4 subnets here, right? Now within the subnet, there will be a connectivity required from one subnet to another, because the web server is in one IP network, the database server is in another IP network, right? So there must be a way to allow communication from virtual machines within the VPC. Now, what if the user is sitting on the internet? Let's say he wants to access the Ola application. So he will not know the IP address of these servers, right? He will just have a application which will have a connectivity through DNS, load balancer, and then to the web servers of your Ola application. Then they will be in return going back to the database server. Now there can also be a possibility that if this Ola application is very heavily used, let's say we are using a load balancer here. This is a Amazon load balancer. Now you don't want to use Amazon load balancer because it does not have a lot of functionality. You can run a EC2 instance here, like how we are running these ones. And on this EC2 instance, you can run a F5 operating system, that is TMOS on this. And you can use this TMOS operating system to load balance your traffic among these servers. You can also have a load balancer here as well for load balancing the traffic among multiple database servers as well, if the connection count is very high. You want to secure access from traffic coming from the internet and traffic going from inside your VPC to the internet. You can also deploy a firewall here. It can be a Palo Alto firewall, or it can be a checkpoint or FortiGate firewall running in a virtual machine in the cloud, right? So you will be able to do the same type of setup what we are doing into the physical infrastructure in the cloud as well. You should know for what functionality, which type of component you should be using within the cloud. All right. Then how the AWS architecture look like? For example, let's say you decided that you want to take advantage of AWS. So you approach AWS and you create an account on AWS, right? So you will be given a root account for your company, a root account for your company. Now with this root account, you will be able to create multiple user accounts. Let's say we have 5 people who are network engineers. Let's say 2 people who are storage engineers. Let's say 10 people who are system engineers, right? Now network engineer will require permission for networking components like transit gateway, let's say route 53, uh, IPsec tunnel creation, direct connectivity, attachments, load balancer. So these services will be accessible only for a user who has the network administrator permission. The person who is responsible for storage, only he will be able to see the storage component. Network administrator may not be able to do any changes into the storage. For the systems, like you are running the virtual machine in the VPC and you want system administrators to have access to it, only the system admins will be able to log in into the systems which is running in a virtual machine. You will not be having permission as a network administrator, right? So that is how a root account can create sub accounts within the AWS, and the permission can be attached to each account based on their roles and responsibility. Once this is done, let's say you are creating the VPC. Let's say a single company may have multiple accounts. Let's say this is uh, uh, one of the unit. Let's say I'll consider one of the bank, for example, HSBC Bank. Now HSBC Bank have various services, like they have credit card, they have retail banking, and then they have, let's say, personal loan, right? Now when it comes to the credit card department may need multiple compute resources, right? They want to have a development application team is developing some application, so they want to just put it on a staging environment. They have a requirement that there should be a computing where they can put the code on the staging stage. Now they want to move that code to the testing machines, so that the application can be tested related to the credit card and so on, how customers can use their credit card swipe, how offers will be generated, and so on. Once it is done with the testing, it will go into the initialization phase. And finally, if it is approved by the business that everything is working fine, the application will be sent into the VPC where the production servers are running, right? Now, this is for credit card department. Same thing goes for your retail banking, for your personal loan, or maybe any other service like home loan, mortgage, brokerage type of services what uh, a bank is offering, right? So for each type of business, we can have multiple accounts within the root account. And the people who are responsible for retail business may not have access to the credit card uh, setup. They may not have access to the personal banking setup and so on. So there is a segregation of duty within the cloud as well that can be done with the help of this. How does a VPC component look like? For example, let's say I want to run a service, right? Let's say a website, right? To run a website, what we need? We need a computing power. So the computing power is, let's say, EC2, elastic compute here, right? Now this EC2 will require a operating system. So I can run, let's say, Linux or Windows on this. It will also require a application like, let's say, Apache server or maybe IIS to run a website, right? And then uh, it may also be linked with a database storage, which is in a private subnet, right? Now, when a user wants to access this website, what I have developed or the business have developed, user will always try to access with the www.abc.com name, right? So to resolve this, I need a, let's say, Route 53 service here, right? I don't want to run a separate DNS server, so I can use Route 53 service within this, right? Within the AWS. It is not part of the VPC. Instead, it is part of the AWS Cloud Route 53. So whenever user will try to resolve www.abc.com, their query will go to the AWS Route 53. Route 53 is going to give a IP address, which will be of this EC2 instance. If it is a private IP address, I will also need a NAT gateway here or an internet gateway that can allow communication from end users to reach up to this EC2 instance. Now there can be a possibility that this VPC also needs to communicate with another VPC. So I need a transit gateway, TGW. Transit gateway, which can allow communication from one VPC to another VPC. So there will be another TGW here, and there will be private subnets like this, uh, private and public subnets within this. Same will have here as well, right? So we can create a logical separation of networks within the VPC, like how we do on-premise. Now, how does it looks on the on-premise? Let's say I have an office, and office needs a internet connectivity. So let's say this is ISP router. Here we generally place a firewall, right? So basically your firewall is a logical separate. Your firewall is separating the public and private concept. From here to here, it is all public, right? Anything behind your firewall, let's say it is your private network, that is your LAN segment, right? So there is a boundary, what is public network within our control and what is the private network within our control. Same type of setup we can do within the VPC as well. We can separate the logically separate public network and the private network based on the security groups and the IP subnet that we can allocate to a network within the VPC, right? If I want to allow any connection, let's say coming from the internet on specific port, for example, let's say TCP port for HTTP traffic or HTTPS traffic, I can control the connection with the help of a security group. Security group is like set of access control list that we write on a firewall. Who can access HTTP service, who can access FTP service and so on, that can be controlled with the help of a security group that we can directly attach to a virtual machine, or it can also be attached to other networking components as well, right? So to control who can access what, we can use the security group. There is also a concept of network ACL that can be used for controlling the connectivity coming from outside to our VPC, which is going to be almost similar like what we do onto the private network. What AWS says is there are certain services like Route 53, Amazon CloudFront, AWS identity management, like your username and password for accessing the cloud. These are all global services. Let's say it is not part of your VPC. VPC is where you are managing this privately, right? Your Route 53 is a global service. It cannot be part of your VPC, right? So whenever you are subscribing for this, it will be directly accessible from the internet. You will not have to get into your VPC private network to access this service, right? Similarly, they have some services which are outside of your VPC. You are more concerned about the internal component of your VPC and how these internal components can be able to connect with the external component. We will be taking care from the networking side of it. So as a network engineer, I should figure out that if my traffic is going to reach to a DNS service, that is Route 53, it has to exit the VPC first and then reach to the Route 53. So how are you going to allow that? You may need to have an internet gateway attached to it, IZW, or you may need to have some other service like NAT gateway so that you can hide your private IP addresses when they are going to communicate with a Route 53 or so. What is the time? I did not look at it. I don't want to drag for a longer time, right? But just to keep in mind that within the VPC, you will be able to logically separate the network components based on the IP subnetting, and you can designate which subnet will be considered as a public subnet and which subnet can be considered as a private subnet, right? There are logic to understand that if a subnet has a default route pointing to a IGW, internet gateway, it will be considered as a public subnet. If a subnet does not have a default route pointing towards the IGW, it will be considered as your private subnet. That is the logic behind which subnet is a public and which subnet is a private, right? So any subnet which does not have a route towards this default route and attached to a IGW component, it is considered as private. And whichever subnet has IGW attached to it, they will be considered as public. VPC gateway. What is VPC gateway? For example, let's say we have a VPC in the cloud and we have our on-premise data center, right? And you want to allow communication. Some of the web application what we are running in the EC2 in the virtual machine, they needs to communicate with some database servers which are still in our data center, physical data center, right? So I want to have a secure connectivity from these application servers to reach to the database server. And for that, I can have a VPN gateway, right? VPN gateway component, which is a kind of service within the VPC, right? So you will be using a VPN gateway service in this VPC, and through this VPN gateway, you will be able to establish a VPN tunnel with our on-premise router, which should support IPsec protocol, or it can also be your firewall, any vendor firewall through which we can establish the tunnel from VPC gateway to our firewall and so on. And through internet, you will be able to allow this VPC to communicate with our on-premise data centers, database servers, right? Not only this, let's say you have some employees here and they also want to access these resources. I can allow these employees to go through the VPN tunnel to access these virtual machines. It can be a Linux machine, Windows machine or so. It can also be a load balancer somewhere here or a firewall. They all can be allowed to access through your VPN tunnel as well in a secure way. All right, so this is example what I said about the public subnet and private subnet. So this subnet, this is a CIDR block for this entire VPC. I have chosen that I will choose this CIDR block for this entire VPC. Now within this, I have multiple subnets. Let's say subnet 1, 2, 3, 4, 5, there are 6 subnet, right? Now, out of 6 subnet, what we have done here is we are considering these 2 subnets as a public subnet, right? Why we are considering them as a public subnet? Because if I look at this one, right? Let's say one of the subnet, where is that? Let's say I'll consider this way. So when I look at the routing table of this subnet, it will have a address 10.10.0.0 /24 1, and then it will have a route here. This will be considered as local subnet, right? And then it will have a route 0.0.0.0 attached to a IGW, right? So whichever subnet is attached to a IGW, that is having a route to 0.0.0, that subnet will be considered as a public subnet. So every subnet has its routing table, right? And routing table will have route to route the traffic within the subnets, right? Uh, from one subnet to another subnet. Any subnet routing table has this route. That means it will be considered as a public subnet. A subnet which does not have route for 0.0 pointing towards the IGW, it will be considered as a private subnet, right? Communication from your private subnet to public can be allowed with the help of NAT gateway or any other service what AWS is offering, equivalent to what we use in our on-premise, like firewall has NAT capability and so on. Similarly, AWS has NAT gateway within the cloud. About the hybrid connectivity, I already spoke about it, but this is again, you can allow communication from your cloud computing devices to access your corporate data center, that is your physical data center. There are multiple ways to allow secure communication from your private computing to data center. We have VPN, which I spoke just now earlier, and there is another option where there is a concept of direct connect. This is a very high speed connectivity what AWS provide. All you have to do is you have to run a VPC gateway here, which provides the direct connect capability. Now, you will have to, as a customer, you will have to approach a service provider who is providing the direct connect circuit up to your infrastructure. So let's say in India, maybe Tata, Airtel, or maybe Reliance may have a tie-up with AWS where they're terminating the direct connect links, and they can provide you a direct connectivity up to the speed what you are looking for. Maybe you are looking for 50 Gbps throughput or 100 Gbps throughput for transferring files in a more faster way. They will be providing you the fiber links to transfer the data in a faster way. So this is again a kind of service that you will have to subscribe, and AWS charges on this circuit is based on the data transfer. How much data you are transferring through the direct connect, they will be charging on the data transfer rate, not for the service, right? So your costing will always be depending on the how much data you have transferred through this link, right? It is a very costly solution, but it is used for moving all your workloads from on-premise data center to cloud environment. That means copying all the resources, configuration and everything into the cloud. All right. Then there are certain things which are regional, like if you look at this S3 bucket DynamoDB, you will not have to be worried about what DynamoDB and things means. S3 is like what we say platform as a service, right? So let's say you have a website and you just want to be focused on developing the website. You don't want to see where you don't want to be worried about where to run this website, right? So what AWS says is we have a S3 bucket. It is a kind of storage service. You just dump your web pages in this, and your customers or users will be able to access that website. Of course, there will be a basic configuration required within the S3 bucket when you are dumping the files, like it should be linked with a domain name. You should create a domain name into the Route 53 and so on, and your application will be easily accessible. So some services are regional. That means if you are using the S3 bucket in Mumbai region, right, you cannot use the same S3 bucket in, let's say, North America region also. You will have to do the same thing in North America as well. You will have to buy a service in North America region, and you will have to put that same content there as well. So that is how some services are regional, and it sticks there. Now, this is a very high level application traffic flow. Let us say that I will take an example for this. It can be your Hotstar application, right? What is a Hotstar? It's a web content delivery application through which you can watch movies, you can watch live matches, you can stream content, and so on. So as a user, someone is typing as Hotstar or using the application to access the Hotstar. The query will be going to the DNS server to resolve the Hotstar IP address. And then finally it hits into the AWS, where a load balancer will come into the picture. Why load balancer? Because we have millions of Hotstar users, right? And query needs to be distributed among the multiple web servers. They are being load balanced on a load balancer, right? Now this uh, web server will be mapping with the application server. What is application server? The Hotstar application that we use, right? So how the application is designed, it will be on the application server. Now, since we are talking about many of the customers like users, we need to maintain the database. Like you are a customer, what subscription you have on Hotstar, how much time you have consumed, what data you have been consuming. Those information will be maintained into the database servers like relational database or SQL database and so on. Now, at the same time, as a user, uh, sometimes you might be uploading some files. So what type of files you are uploading on, let's say, Hotstar? That can be examined with the media file types, content filtering can be applied, and so on. And that is how your uh, application like Hotstar can provide you a better service, right? There are some notification services like when your subscription is going to expire, when a new movie is uploaded on Hotstar, you will be getting some notification and so on, which will be linked with the application, right? So this is how generally a company uses this platform for deploying a application rapidly into the environment, into the AWS. Now, a company has to be focusing on developing an application. They will not have to worry about from where they are getting the storage capacity, from there, from where they are going to get a compute for application server, from where they are going to get a computing power for your web server, where they can run the load balancer. These things will be taken care by the underlying resource requirement is taken care by the AWS. You will have to just spin up a virtual machine as per your need, and you can run any operating system in these virtual machines as per your requirement, application requirement, right? So we are almost done. The same thing what we have seen in the earlier slide is replicated in the symbols what AWS uses. So this is a load balancer symbol. We can see user connection hits on one side and it can be distributed on multiple servers, right? This is let's say Route 53. So if someone is typing www dot let's say hotstar.com, first connection will go to the Route 53. Route 53 will give the IP address, and then your connection will hit on the load balancer. Now load balancer will distribute the connection among multiple servers. I can have plenty of servers. I can have 10 servers here or 20 servers as per the usage of that application, right? Additionally, I can have the same load balancer also load balancing the traffic on the application servers, right? So I will be routing the traffic from web server to the load balancer again, and load balancer will send the request towards the application servers again, right? So this is a symbolic representation what we saw earlier for a application. How does your AWS console looks like? So when you create an account for your company, right, you will be given an account name based on your company name, and you will be given a root account. Once you log in within that, you can create user accounts for other administrators like system admins, network admins, storage admins under this IAM, Identity Access Manager, is where you will be creating accounts for your administrators. If you want to run a virtual machine, you'll go into the EC2 instance. If you want to create a virtual private network in the cloud, you will be doing in the VPC, right? And similarly, we have some other services that we can list from here. You want to search any service here. Let's say you want to look for Route 53, just type here and you will be seeing Route 53 option here to select. Go into it and create your DNS records and so on. So that is how AWS is providing a simplified console for setting up a private network into the cloud, AWS cloud, and you can run the resources within that, right? That's it for the day. Does anybody have any questions? I know it's a bit late, but I hope I was able to walk you all through like how easier it is to relate what we are doing on the on-premise network and how the same thing is being done into the cloud. If we focus on our roles and responsibility and the component what we are using in the physical world, the similar type of components can be used in the uh, cloud world as well, and our responsibility is going to be for managing those components, right? Without having a network administrator, a company cannot simply go into the cloud. They will need a network engineer, they will need a security engineer who can design the private uh, uh, private network within the cloud as well. All right, Samir, you have a question. Yes, you raised a hand, Samir. You want to ask anything?
Hello, sir.
Yes.
Hello, sir. My name is Pradeep.
Okay.
Right now, I'm working in the telecom sector. I have one year of experience. Basically, I work on the routers, switching, routing, and the basic things, static routing.
Huh.
So for me, is it worth to directly go to the cloud, or should I go through by step? First, I have to learn firewall, security, then the cloud, or is it okay to directly learn AWS?
There is no harm in adding a skill in your profile, but always keep in mind that if you do not have a thorough understanding like how a router work, how a netting work, how a security policy is configured on a firewall, how a load balancer work on on-premise, you may not be able to easily correlate that in the cloud. It will be difficult for you to visualize those things into the cloud. So a learning may be a challenging task in that case. But if you understand how all these things work on the physical infrastructure, it becomes easier for you to go with that. But there is no restrictions or limitation as such that when you should start learning the cloud. The early you learn, the better it is for you. All right. I see that just a minute. I see that most of the people are now dropping up. I know that it's late for everybody. I would like to say thank you all for taking out your valuable time and joining us. And I hope that I was able to uh, uh, give some information which will be useful in deciding what you will be learning in the cloud and how it can be beneficial to you. All right. So thanks all for your time and listening to me. If you
Krishna,
have
one
any
one last thing. When you are planning to start the batch?
as of now, the dates I have not finalized, and the purpose of this session was not to attract people for my classes. Uh, Maybe this is the first AWS class I'll be conducting. I do not have the date, but if you talk about the other classes, we do have plans for them, and they are in a they are going on in a recurring basis, right? But this
Yeah.
session was only to guide people that how easy it is to correlate your physical infrastructure with the virtual, and how easily you can learn the cloud platforms
Yeah, it
in
was a wonderful
comparison.
session, and I personally want to add the AWS or cloud skill in my portfolio. So yeah, I'm quite interested in learning the cloud.
All right.
Thank you.
All right. Thanks, everyone. Anybody have any question you want to ask? I can take few of the questions.
Yeah. Hello.
Krishna, hi.
Yes, Harish.
Yeah. Means this is the AWS batch, or you just give the introduction about the AWS?
I am just trying to guide people that how you can focus on learning the cloud platforms in relation with what you are doing in on-premise network.
Okay. So in that, you will provide the practical also.
The
Means how we
batch
can create the instance and this.
yes, my most of the trainings, whatever I deliver, it
Okay.
is completely practical oriented, and I share the actual real-time knowledge what I have gained so far.
Oh, okay. So in this session, you will cover the practical also.
Yes, everything will be demonstrated what we do in real time.
Okay. So it is a chargeable or?
Yes, sessions are all my sessions are chargeable because they are effort taking,
Okay. So
and
how
I
much
don't.
fees? You,
Fees is 15,000 for all these technologies like for
okay.
firewall and so on. For AWS, we have not decided the fees as of now. For these, I charge
Okay.
15,000 individually for each topic.
Okay. Okay. Means if I want to learn a blue code proxy, so for that 50,000 is fees.
15,
Okay.
15.
Yeah, 15, right. And
Yes.
AWS, you are not decided to fees.
We have not decided the fees as of now.
Okay. Okay.
But I try to keep all the fees as low as possible, considering my efforts
Yeah.
speaking
Actually,
and
I'm interested. That's why I ask you. It is
okay.
a chargeable or a free class?
No, it is chargeable. Yeah.
Oh, okay. Thank you.
All right. Thanks.
Hi, sir.
Yes.
Shakir this side.
Yeah, Shakir.
Yeah, actually, I want to confirm that if we planning or if we are planning to do the AWS, so which course we should do as per the network perspective? Because there I can see there are many courses over there in the AWS, like associate and something. I'm not sure, but there are many courses there.
And that is where the confusion starts actually. Most of the people who are trying to learn the cloud, right?
Mm-hmm.
They don't focus the learning what is relevant to them. They just
Right.
try to go and attend a class about the cloud, maybe Azure
Right.
or maybe your AWS, right?
Right.
My intention is to guide you that you will not have to focus on things which are not relevant to you, right?
Right. That's
and
right.
and
Right.
and if I'm delivering or training on AWS, my course content will be designed in such a way that it is focused towards the networking, network security, and cyber security side of the AWS infrastructure. I will not be focusing on the database administration, system administration, or development side of it.
Right.
Because it's not my area of interest. If that was my area of interest, I could have joined the development side of it, right? So that is how I'll be designing. But in industry, when it comes to the institutions and so on, they are simply selling the courses uh, uh, in different names, I will say, like associate level and so on, and they are mixing up all the technologies, which is not at all relevant for
Necessary.
everybody. Yes.
Right.
So it is a kind of waste of time, waste of money a individual is spending learning those things which is not relevant, I will say.
Right.
Yeah.
You meant to say that if you are going to teach that AWS, you will only teach us regarding the means like I'm from the background networking, so you will
It will
teach
be
us the
purely relevant to the networking,
networking
like
only.
yeah, how you can deploy firewall on firewall load balancer in the cloud, how you create a transit gateway, how you connect VPCs, how you will be setting up the direct connect circuit and so on. All these things will be covered in my sessions.
Okay, got it. Thank you so much. Thank you.
All right, no problem. All right, anybody have any other questions before we wind up for the day? No. All right, so most of the people who joins my sessions, they come through the references, and I really appreciate people who has been helping reach me to many of the people, right? And keep doing that. I'll try my best to give the best knowledge what I have so far, which is relevant to your career growth and so on. Keep learning and keep supporting.
Thank you, sir. Thank you, sir.
Thank you so much, guys. Bye-bye.
Yeah, thank you, sir. Thank you so much.
Good night.
Thanks, Krishna.